welcome to 5 Minute School. In today's video we're going to be looking at the digestion and absorption of fat. So here we have a simplified drawing of a triglyceride. Most of the fat present in the human body is in the form of triglycerides, which are 3 fatty acid chains bound to glycerol. And it's not the only form of fat which is present in the human body. We also do have phospholipids and sphingolipids, but we're going to be discussing triglycerides for now. So fats and lipids are hydrophobic and are not soluble in the aqueous environment of the digestive tract. The salivary glands and pancreas produce lipase enzymes which are responsible for lipid digestion. Majority of lipid digestion occurs in the duodenum via pancreatic lipase, which binds to the lipid droplet surface with the help of colipase, which is also produced by the pancreas. So pancreatic lipase works by binding onto the lipid droplet surface, and colipase helps pancreatic lipase, and it helps it by binding it onto the lipid droplet surface. So it works as sort of an anchor, so it anchors the pancreatic lipase onto the lipid droplet surface. So lipid digestion is made more efficient by emulsifying fats into smaller droplets, and this is done by bile salts which are present in the bile, and they emulsify the fats, and it increases the overall surface area of fat droplets available for digestion. So the whole effect of this is to break down the larger fat droplets into much smaller droplets, so there's a higher surface area for fat digestion. Bile salts are amphipathic, which means they have a hydrophilic end and a hydrophobic end, and once they have emulsified the lipids into smaller droplets, they coat the surface of the droplets to prevent reassembly back into larger lipid droplets. So they cover the smaller droplets to prevent them joining back together. So here we have the two forms of lipase. We have lingual lipase and pancreatic lipase. Lingual lipase is secreted by the serous glands. It has an optimum pH of 4.5 to 5.4. It doesn't require bile salts for its function, and it catalyzes the digestion of triacylglycerides or triglycerides to diacylglycerides or diglycerides. And that's the main product, diacylglycerides. And some enzyme activity continues in the stomach, so there is a small amount of lipid digestion which occurs in the stomach, but it's at a much smaller scale in comparison to the digestion which occurs in the small intestine. And lingual lipase accounts for 30% of lipid digestion. Now we have pancreatic lipase, which is secreted in the pancreatic juice. It has a pH optimum of 8. It requires bile salts and colipase to increase its efficiency, and catalyzes the digestion of triacylglycerides to monoacylglycerides, and it's responsible for majority of lipid digestion. And finally, we're going to talk about a different type of fat or lipid known as phospholipids. And the enzyme phospholipase A digests phospholipids, for example lecithin, into free fatty acids and lysolecithin. Remember, phospholipid consists of two fatty acids bound to a glycerol which has a phosphate group attached onto it. So after the digestion we get two fatty acid chains and a lysolecithin, which is what's remained without the fatty acids. That's everything we're going to discuss today on the first aspect of the digestion and absorption of fat. The next video will be focused on the absorption of these lipids. Thanks very much for watching.